It's been a couple of years since we've had a safety meeting, I believe, as I recall, and we ought to have at least one a year, I think, maybe two sometimes. The topic of shop safety is quite extensive, and we can easily have two of these classes a year to cover the basics of shop safety, as well as toxicity can be a whole nother class. But what I wanted to do for this meeting is do a little research on the types of injuries and the statistics of injuries in shops. And I found 2 or 3 studies that are pretty interesting. Show the first slide and then go to the second one. There was a study published in 2003 from the Journal of Hand Surgery in America that talked about the number of injuries and the types that hand surgeons see sometimes. Go to the next slide. They estimate 720,000 injuries a year in the U.S. in both professional as well as amateur. 60% of injuries that they see are by amateur woodworkers. 42% are by the table saw, and 37% have some kind of amputation, usually finger amputations. 27% require hospitalization, and 22.8% are treated actually by hand surgeons of those numbers. The causal factors that they came up with were, as you can probably guess if you watch anybody use a table saw, the missing guard in a table saw. A lot of people will take the guard off, and that's one of the causal factors that they determined was so important to hand injuries. Fatigue in the shop, and postprandial somnolence, sleepiness after you eat. That was an important factor they found. So if you eat a big lunch, you take a little nap before you go back to the shop, perhaps. The next slide shows a kind of a student population from Ontario. This is from the Ontario School Board's Insurance Exchange. Insurance companies, of course, know all about injuries, and they have all the statistics there. They found that, let me just kind of go around the circle with the graph there. The blue area, 44%, are bandsaw injuries. The next one, 4% hacksaw. The next one is 2% hand saws. The next light blue one there is jigsaws, 3%. 13% scroll saw injuries, which is kind of a little surprising to me. And then the 25% were table saw injuries, 3% radial arm saws, and then 5% other types of saws. Now this is the student population, and I assume, I'm guessing that they have a number of band saws and a number of scroll saws. And of course, as you increase the frequency of use of a particular saw, then the percent of injuries by that saw is going to be increased accordingly. So if more students are using band saws or scroll saws, the number of injuries are probably going to increase by that much.
So it didn't get into any details about the nature of the injury?
No, I couldn't get the entire printed article. I only got the abstract, but I thought it was kind of an interesting population of students that would be a little bit different than what you and I would see, or a professional woodworking shop would see. Another study, this it's pretty good one, I think it's pretty complete. The next slide is the Consumer Product Safety Commission, which is a U.S. government type thing. They keep statistics on a lot of injuries, as you can imagine. And they found that in 2001, the emergency room treated injuries were 418,000, about almost 419,000. Medically treated injuries in 2001, not necessarily ER, but all medically treated injuries, 960,000 some odd. ER treated hospitalized patients, 3.3%. There were 183 deaths in the year 2000, and the number of incident reports in 2002 was 580. Now, of these numbers, the hand tools, not power tools, but hand tools, were probably the most prevalent injury producer. 30% were by hammers. As you can imagine, your hand's pretty close to the nail or whatever you're trying to hammer. 39% were lacerations by a retractable knife. Of the deaths reported in the year 2000, only 41 of the 183 that you see there were from woodworking, specifically woodworking accidents. The other deaths involved 39 hoists, lifts, jacks, or jack stand accidents, and 22 were welding, soldering, or cutting torch accidents. This study included 24 different tool groups, and I'll quickly read these to you. The power drills, welding, soldering, cutting torches, manual workshop tools such as a hammer, grinders, buffers, polishers, batteries, battery chargers, painting equipment, sprayers, miscellaneous woodworking tools, power sanders, other portable stationary tools. I won't read all of them to you, but there were 24 in all in this total study. 3 were non-woodworking type tools, such as the hoists and lifts and the welding equipment. The next slide. The cost of the deaths were about $915 million, and the total cost of the medically treated injuries were $15.4 billion. Those numbers in millions, and so the total known costs were about $16 billion. So you would agree, I think, that shop injuries are significant in this country, and the Consumer Product Safety Commission's goal or activity is involved in how to prevent these injuries, and that's what their function is. So what are the most dangerous power tools in the shop? Everybody kind of has their own idea of that. Next slide. And I put together a list of some stuff that I read. It seems like the table saw is pretty much the most dangerous common power tool that you have in a shop. And I want to take a little survey here. How many people own table saws? Okay, that's about 18. There's 21 here today. And that sounds about right. And that involves 33,000 emergency room visits per year and about 4,000 finger amputations, believe it or not. And these may be exaggerated a little bit because they're counting a finger amputation as the tip of a finger being cut off also. So, shapers, how many own shapers in your shop? Not many, probably 3. Okay, yeah. There one type of shaper that I have. I don't own a shaper, but I inherited a shaper attachment from my father. This actually it goes on a table saw or a radial arm saw. This is scary. This is really scary. And on a radial arm saw, this is the guard you're supposed to use for it. Just a little plastic thing like that. I haven't used this in 30 years, I guess, because it scares me to death. It makes a racket you wouldn't believe.
Jim, I knew a guy that one time had one of those blades came out.
Yeah, they're screwed in with an Allen bolt.
But anyway, he said it came out, went across his basement, went through the concrete block wall and fell down inside, and he said he never used it again.
Yeah, I'll never use mine again.
What was the purpose of it?
The radial arm saw, the blade is up in the air anyway. It's not under a table like a table saw is, and and that thing is running around that tiny little yard there. He wouldn't stop anything if it came loose. So.
Yeah, I heard a question out here about what you use the thing for. On a radial arm saw, what you would do is extend the motor out, turn it 90 degrees,
Yeah.
and then proceed to run a piece of stock through underneath the blade to create a piece of molding.
It's a ripping operation, and ripping on a radial arm saw is not very safe anyway.
Personally, I much prefer to use a router table.
Yeah.
That's kind of my machine of choice.
So three out of 21 in this room have shapers. Chainsaws, we'll count that as a woodworking tool because we nearly all, probably everybody.
No.
2, 4, 5, 6,
about 20
7, 8,
hands,
9,
maybe.
10, 11, 12. About 19, 20. I'll say 20. That's about right. 36,000 injuries a year are with chainsaws. Routers, everybody probably raise your hand for routers. Everybody, just about.
Gary's got to stick about 18 hands up, I think.
Gary's got 3 of everything.
I was going to say 19. A router can nearly do what a shaper can. A shaper is usually a much more powerful instrument or machine, but chances are if you can't buy the molding, you can more often make it with a router. Jointer planer, that's supposed to be one of the more dangerous tools. 4.9 incidents per 1,000 hours of use. I tried to get that statistic for all of these, but I couldn't find the rate of accidents on it. How many have jointer planers? Either one. So about 18. Bandsaw, about 4,400 injuries per year reported. Just about everybody, 20 of them. And radial arm saw, about the same number of injuries per year too. Let's count those. That's 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Radial arm saw usage is dropping quite a bit. Most people do have table saws instead of the radial arm saw. Circular saw, portable circular saw.
Everybody's got that.
Yeah, everybody. Every one of us have that. Okay. Next slide. Miter saw, which is about the same as a radial arm saw, but most people have a chop saw, I believe. Raise your hand if you have one. Let's see, about 19. Nailers, air-powered nailers. 37,000 injuries per year on those. How many have those?
Does the air-powered brag guns count?
Yeah. 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 And wood lathe. Wood lathe was never on any of the research that I did. It was not counted as one of the most dangerous power tools, but so many of us here have lathes. I went ahead and included that. How many do have lathes here? Oh, quite a bit.
Look, he stuck his hand up there.
George.
Get that on film, Dave.
About 13. Okay. That's interesting. Next slide. The most dangerous tool in your shop, though, is the next tool that you're going to use, right? Next. All right, let's go into some of the really basic equipment that you really need to have in your shop. First is obviously a first aid kit, something like this. I bought this at Home Depot or Lowe's. Has 170 items in there, and I haven't used it yet, thankfully, but you need one, especially if your shop is not near your house, not attached to your house. If it's in a detached building, you need to have a first aid kit nearby. You got one in here. That's a pretty good one there.
What I would heartily recommend, if you don't have a first aid kit of some sort, those prepackaged kits that you get contain a whole lot of stuff that aren't going to be of a lot of use to you in your shop. So what I did is I built this one for our demos and stuff that we do here, and I just went out and did a a la carte stocking of the thing at about half the price of one of those, and we've got a lot better supply of the things that we're liable to need.
Mm-hmm. Next slide. I consider equipment as the clothing that you wear. You know, don't wear loose clothing. If you have long hair, tie it up somehow. Keep it away. Tie that up, Jimmy. That's dangerous.
Yeah, we have to worry about that, do we?
It might blind you more than it might keep caught. In the last couple of years, maybe the last 3 years, we've had 2 deaths in the country from lathe accidents. One was a young lady at Yale University in their shop, got her hair caught in the lathe, and she actually died. And another piece of wood flew off a lathe to another young lady, actually, in another school. I forget what school that was.
That was at a demo. I think.
Was it at a demo?
It was like one of those, you know, something like Southern States or one of the demos where the lady was demonstrating and the piece came off the lathe, came up and caught her under the chin, knocked her unconscious, sent her to the hospital, and she passed away.
Yeah. So be careful about the clothing that you wear. Don't wear long sleeves normally unless you're spraying paint and you just don't want paint all over you. But using a power tool, typically wear a short sleeve shirt, something like that. Jewelry, don't wear watches and rings. Next slide, I'll show you an injury from a finger. Then you can still see the ring on that finger there. This guy was not in a wood shop. He was actually working on a roof and slid down the roof and caught his ring coming down.
There's a baseball player playing for the Braves, jumped up and grabbed a sign and did that with his finger. One of the better players.
When was that?
Several years ago when the Braves first came to Atlanta.
Wow. Next slide. Okay, eye protection. That's kind of close to my heart recently, lately. I've had eye surgery twice. The last one was Thursday for cataracts. Eyewear, eye protection is very, very important. You know, woodworking tools are made to throw sawdust everywhere. And if you don't have eye protection, these are polycarbonate glasses. And these are the kind you need. You can also get prescription glasses that are polycarbonate. It's a tough material. And I'll show you on another slide how tough it is. You can also get polycarbonates with bifocal lenses. This is a pair with bifocals, if you have to look up close, which is what I have to do nowadays. Other protection, this is a full face mask. This is Lexan or polycarbonate, and it's thick enough just to stop just about anything you'll encounter. It may knock you backwards with a large piece off a lathe, but it usually will not break. This is a breathing apparatus and a Lexan protection, full face protection. I'll talk about the breathing apparatus a little bit more, and it also has earmuffs for hearing protection. This is a Trend filtration system. You can see how it bends. You're not showing it on the screen. This bends a lot. This is really not as thick as this Lexan or this right here. So, but the Trend does a good job of filtration, but not as good of a job as stopping a flying object. Next slide shows an actual pair of polycarbonate glasses. This was from a professional carpenter at the CDC carpenter shop. He did not know a nail was in a piece of wood, and he was using one of the large table saws they have there, and it threw it into the safety glasses, and it stopped less than a millimeter away from his cornea. And the Office of Health and Safety made that picture available to everyone. He was lucky. Didn't know the nail was there. Next slide. This is a disrupted cornea. As you can see, that's what my eye looked like about 2 days ago from the surgery. By the way, too, I learned from my experience. I had a detached retina in October, had that fixed, and if you have a trauma like that, even a surgical trauma, the rate of cataract formation in that eye will triple. So I had cataract surgery on Thursday to replace it. And I woke up Friday morning and sheets of paper were whiter than I've ever seen in years. Everything was much brighter. You don't know that your eye lens has cataracts like that, and it really cuts the light down a lot. So it's really amazing. And this slide is the loss of an eye from not wearing safety glasses. Next slide. Hearing protection. Can everybody hear me? How many of you have tinnitus? Tinnitus? Yeah. Do you think it's from probably woodworking equipment or something else, or a job you had, or any idea what it was? Yeah, I've got it too. Tinnitus is a ringing sound in your ears. Mine sounds like a million mosquitoes right next to my ear all the time. And it'll come and go depending on what I eat. I think caffeine will exacerbate it. I try to stay caffeine free as much as I can. The hearing loss is called the invisible injury because you don't really know what's going on. It's so subtle, and it's cumulative. Hearing loss is cumulative. Over time, if you're subjected to very loud noises, you're going to slowly lose hearing. Whatever frequency it is that the noise is making, those are the frequencies that you're going to lose. I've lost about 15% of frequencies above 4,000 hertz in both of my ears, which means I have difficulty hearing female voices. And so I have a good excuse for not hearing my wife.
My wife thinks I have that.
Yeah. The daily acceptable noise exposure is supposed to be about 87 decibels. A decibel is a scale of noise pressure, sound pressure, and it's a logarithmic scale. But 87 decibels is considered to be normal, that results in no damage now. Peak sound pressure of 140 decibels will probably cause hearing damage. And that you could get that from a nail gun, a carpenter's framing nail gun. This is a very loud tool. Go to the next slide. One of the easiest ways and the cheapest ways to prevent hearing loss is just use these little foam ear cushions. But the way you put them in, you have to put them in correctly. You kind of roll them around in your fingers like that and make them very small, and you put them as deep as you can inside the ear canal, and then let them expand. And it'll take a few seconds to expand completely. And that's the way you're supposed to do them. Don't just take them like that and put them to the outside of the ear. They really won't work that way. You got to put them down in the ear canal. And you can use them multiple times. If they started getting dirty, you just get another pair. They're cheap. Let me give you some examples of when hearing damage can occur using different tools. A porter cable framing nailer will produce about 125 decibels of noise. Each nail it drives. A Craftsman 5-gallon shop vac, 123 decibels. Quite a bit. You can withstand without damage, they tell me, I hear. For 15 minutes, a Craftsman 7 1/4 circular saw, which produces 118 decibels. Since sound is accumulative, it depends on how long you're exposed to that noise. For a tool that produces 110 decibels, such as a porter cable router, you can withstand 30 minutes of that without damage. And again, it's subtle. You won't know it. It's the silent injury, the invisible injury. An hour of a router table producing 105 decibels or a DeWalt biscuit jointer at 105 decibels, 10-inch miter saw, 105 decibels, a rigid 13-inch planer, 104 decibels, Milwaukee Sawzall, 103 decibels. You can withstand an hour of that without damage, they say.
How much does a sander, those little hand sanders do?
A Craftsman handheld belt sander, 101 decibels. Of course, it's a logarithmic scale, so 101 decibels is a good bit quieter than 105 decibels. Portacable finish nailer, a pneumatic finish nailer, 101 decibels. Milwaukee jigsaw, 101 decibels. Portacable random orbit sander, 102 decibels. And you can withstand about an hour and a half of any of those without damage. 2 hours.
Question.
I ran across something a couple of weeks ago. I haven't actually put it to use yet, but if you have a smartphone,
Yeah.
are you getting to that?
No, I've used it. Yeah,
There are
go
apps,
ahead.
free, this is a free app.
Yeah.
So if you've got a smartphone, that's an Android. I'm sure they've got an Apple version as well. But there are apps where you can actually measure sound.
Yeah.
Oh, and also while I've got the floor, my wife is a doctor of audiology. She has an office at the corner of Beaver Ruin and 29 at the Kroger Shopping Center. Her office, they make custom ear protection. If anyone's interested, she'd be very happy to.
What's the noise reduction factor on the one she could custom make?
I have no idea.
About the best foam type you can get is 33. It fell down that whole
Way
thing.
beyond that.
33 is about the
We're a
limit.
bit beyond that.
I'm sorry. How much more beyond the 33?
I don't remember. I've got a custom set I had made. They're just a pain to put in, but once they're in, they're called swim plugs.
Uh-huh.
Those suckers are, when you get them color coded,
Yeah.
you pick the colors for a big shop. When I was a safety coordinator at my place of employment prior to retirement,
Uh-huh.
and tried to get them. There's even programs so they'll come around and do it right there. And you couldn't get management to spend money on anything.
Yeah.
My best plugs were, I can't remember the brand of them, they're a light blue color with a yellow vinyl cord. They did not require compression, and they had a clear coating on them. You insert, quarter turn, that's it.
Yeah, I've seen those. They're a little harder material than this is, I
That's what
think.
she's made me. I've got a couple of sets.
Yeah, so, yeah, they're fabulous. I just can't remember the name of the brand. They're very good. They're very popular.
Now, what I'll do sometimes, for example, if I'm using a chainsaw, which is very loud to me, I'll put the foam plugs in, and then I'll put this on top of it.
Yeah.
And that decreases by another 10 decibels, the noise. I mean, you can hear yourself breathing almost while the chainsaw's running. It's amazing. And here's another kind too. It's kind of it's more of a wax. It's a little harder stuff here, and it fits deep inside the ear canal. If you want to listen to the radio, you can get something like this, but don't distract yourself by listening to the radio and have an accident.
Will that not affect your hearing with using those kind of things?
Like the radio part,
Radio?
if you keep the volume down, you're okay. This has a noise reduction factor of, it doesn't say, about 32, 31, 32, I think.
Definitely affects the blood pressure when you listen to talk radio and operate power tools.
Yeah. Okay, dust collection. Now, yeah, good. Sawdust is a carcinogen. It's known to be a carcinogen. Some woods are worse than others, and that's a whole different class. I've done a toxicity class from sawdust, and I'll be glad to do another one in the future. But let's just kind of leave it at that. A lot of people are allergic to some types of wood. Coca-cola is a bad one. Teak is another one. YEW is another bad wood. There's a lot of them out there. If you develop a sensitivity to the wood, it's going to be worse the next time you're exposed to it. Just ask Don Bedell.
Yeah, he brought up, or he alluded to something there where that stuff will creep up on you. I've noticed myself this past week, my tolerance to Coca-Cola is going down rapidly.
Yeah.
After very short exposure to that stuff, I was
In my
all stuffed up and sneezing. And
in the toxicity class I teach, I have a picture of a guy who had a Coca-Cola bracelet, and he had a red blister all the way around his wrist where he wore it.
Carlton
He did-
McLendon, I used to know him before he died, and he got some Coca-Cola logs at one time with a chainsaw, put him in the hospital.
Yeah, bad stuff. Yeah. Next slide. You can test the dust in your shop very simply, just using a little box fan like that down there. Put a filter in front of it and run the fan. And every shop will have a ring of sawdust in it that if you're active in the shop. You can't really get away from it. Next slide shows one solution to that. This is a jet dust bag collector. You can get bags as far down as 1 micrometer pores, which is pretty darn good. I think I've got a 5 micron filter on mine. A good place to buy the additional bags at the low ratings there is AmericanFabricFilter.com. AmericanFabricFilter.com. Next slide shows the Cyclone. This is a little better design. The Cyclone dust collector will pull a whole lot more air through it, and that shows a canister type filter system there too. And you can get the canister types at porosities that are very, very low too. Next slide shows a dust collection table. You hook up a dust collector to this. The actual place you hook it up to is on the other side of that picture, but it's a downdraft table. If you're sanding, just put the stuff on that and turn on the dust collector. Next slide shows a room filtration system. This is a jet, cost about $370. They're good though. What I like to do on mine is when I'm done at night and when I'm closing down the shop, I'll set it on the timer, about 2-hour timer, and it'll run for 2 hours and then shut itself off. So it'll filter the air in the shop pretty good. Another one cheap way of protecting yourself is one of these masks here. This is a NIOSH N95 mask, and it's a personal protection. You can wear this if you're sanding something real close to you, and it'll filter out. I think I have the numbers here. It'll filter out between 0.1 and 10 micron particles, which is pretty good filtration, and they're pretty cheap, and you can reuse them. You can see this has been used a lot of time. You can also get charcoal impregnated masks if you're using a solvent that you don't like to smell. It's maybe not good for you. That work pretty good. However, when you stop using a charcoal mask, put them in an airtight container, because if you leave them out on the bench like that, they will continually absorbing everything in the air, and pretty soon they won't be any good. So when you're done with them, put them in a zip bag or some kind of airtight container. Next slide, gloves. There's a lot of different kind of gloves out there. I like the nitrile gloves. They're usually blue or purple, and I like them particularly because you can spread super glue with them with your finger. They don't stick to the nitrile. Next slide. Ventilation respirator for paint. I didn't bring my respirator that I use sometimes for spraying paint, but you've all seen the canister type of respirators, especially for solvent-based paints. How many use only water-based paints and stains nowadays? 1, 2. I try to use only water. The rest of you, I guess, use solvent as well as water. The water-based paints are getting better and better. They really are. The stains even are good too. Let's see. Next slide. Don't test a sprayer with your finger, because the next slide will show you what might result. You can get a toxicity reaction that might require extensive surgery. You don't want to do that. You know. Next slide. Fire extinguishers. Next. Get a ABC type fire extinguisher. This is a chart showing the different types of fire extinguisher. ABC covers just about everything you'll have in the shop, unless you're doing some metal stuff with magnesium, lithium, titanium, or the K-type is for cooking oils in a commercial setting. An ABC type, not only will it's usually a dry chemical type fire extinguisher. The B and C designations are given for also the sizes of the area that you need to cover. And let's see. Okay.
You know, and on there, you haven't, it's not listed, it's a D type, it's for
T.
magnesium.
T for magnesium?
D is David.
Oh, okay. All right. Halotrons, there used to be some halon extinguishers. Halon is no longer allowed because of environmental issues, they say. The halotron is another type that's an ABC that you can use in the shop, but they're expensive. That's $320 there for that one. You can easily buy a dry powder extinguisher for the shop for $20 or something like that. Really,
If you
really
get
cheap.
the things refilled, Jim, where do you go?
I never tried to refill one. I've never had to use one.
There's
So,
companies, there's
but
companies that do, just look, well, yellow pages, you'll find it.
yeah,
You'll find it.
I think they require dry in an industrial setting. Dry type extinguishers require replacement after every 12 years or something like. Do you know the?
6 years hydro
Is it
test.
6 years?
Let me see, what is it? Well, we did annual testing too.
Mhm.
Well, that's a quick, 6 years, they have to do something in 12 years of replacement.
Yeah.
Get the
Yeah.
highest number rating you can get on your extinguishers, on your A, Bs, and they will be different. A will be different than the B and C rating.
Yeah.
Also get it with I won't get into the name for it, but the rubber hose onto it.
Hmm.
Because you can direct the fire,
Yeah.
the
Get the larger.
discharge very carefully.
Get the largest one you can afford too.
Amen.
Because if you have a big car, you're going to have a big one. Yeah.
Minimum of 10-pound ABC.
Yeah, for the halotron to be an ABC, it has to be 11 pounds or more. But it's really good. It's great for, in our setting at CDC, for example, our instruments were so valuable and so sensitive that a dry powder extinguisher would ruin a $1 million instrument. It would take months to clean that instrument up. So we had a whole room that would release halon. It'd give you a warning to get out, and it would release halon in the entire room. So,
Jim, for some folks that may not know what that halon is, it's an oxygen scavenger. And if you happen to be in the area and didn't get out, you'd suffocate.
yeah, you would suffocate if
10
you
seconds.
got stuck in there. Yeah, that's why you have the alarm system for you to get out before it releases. Basic safety equipment. Next slide. This is some real basic stuff. This is one of the most valuable safety devices in your shop. Have a telephone nearby, a cell phone preferably on your body, or any kind of phone nearby. Because if you need help, you're going to have to call somebody. You might not be able to get out of there on your own power. Next slide. Electrical equipment. Use the correct capacity on your circuits. Don't overtax the circuits, and use the correct gauge cords if you use extension cords at all. Tommy told us about a problem with circuit breakers, older circuit breakers. You remember
I
that?
had some circuit breakers in my house that actually went, the breaker itself didn't go bad, but the little prong parts that slip onto the, what do you call it, the bus bar in
Yeah,
there.
yeah.
There was bad connection there, and they burnt right there.
How can you test for that though?
I don't
I don't-
really know.
Yeah.
All I know is that the circuit quit working, I went looking for it, and that's what I found.
Mhm. Mhm.
That was an older ITT box, I think it was.
Set early 70s?
Yeah.
Something like that?
73
Okay.
was when my house was
Yeah.
built.
Okay.
One of the symptoms that those will give you is if somebody happens to be standing near the panel when you're,
Well, you can hear it.
yeah, it'll make a noise.
Yeah,
That was how I, uncovered a problem with mine, because my wife executes her hobby right in front of the panel. And
Kind of a buzzing noise?
yeah, exactly.
Yeah.
She said, how come when you're down there it makes all this buzzing noise?
Yeah.
Jimmy?
So
In past years, I've been in industry and we had to do annual checks on our load control centers, and professional electricians will have an infrared device that you can look at your panel with, and you'll see that heat
Hot
effect
spot.
from a bad connection.
Okay. Interesting. Okay, next slide. Let's talk about some burns. Usually these are thermal burns, chemical burns, electrical burns, whatever they might be. First degree burn is like we've all had sunburns from time to time, or just touch your finger on something hot. It's not really dangerous. You just treat it with some ointment or something. But a second degree burn is a little worse. You start forming blisters. First degree burn and second degree burns are very painful because all those nerve endings are just going crazy. You'll always get the blisters though with the second degree burns. See a doctor because they can become infected easily, especially if it's a large area like you see in this picture. Next slide is a third degree burn, and it's extensive. Go to the emergency room, get help, get yourself there. The next slide shows a fourth degree burn, which goes all the way down to the bone and the deep tissues. That is very dangerous. Get to the ER as soon as you can. I think that was an electrical contact right there. Next slide, emergency lighting. If you're working at night in your shop and the power goes off like it did last night with us in our house, it was in the daytime then, but you need some kind of emergency lighting, or just keep a flashlight in your pocket or one nearby so you can find your way out. It can get pretty dark when all the lights go out, especially the street lights in your neighborhood. It's amazing how dark it can get.
And you gotta remember too that your cell phones nowadays have emergency lighting built into them.
That's right. That's right. Yeah.
one of the things that is really handy and affordable is same place that you would go down to like Home Depot or Lowe's, and you would get some of the safety equipment Jim has mentioned, like the fire extinguisher. They also sell emergency lights that you can just mount one of those things up on the ceiling and plug it into a ceiling outlet of some kind, and when the power goes out, this light comes on.
Yeah. Has a gel.
I invested in one of those when I was down in my basement, cutting something, and all of a sudden the power went out, and I'm standing there in the dark, and I'm mild panic there, thinking, okay, what was on, so I can shut it off before
Yeah.
the power comes back on.
The last slide showed one of those battery backup lights in the ceiling.
Yeah.
Good working practices. Let's go next slide.
As a matter of fact, that's a shot from my house.
Is that yours?
Yeah.
Okay. Next. Working practices. These are things that everybody ought to know, but let's go over them pretty quickly. Keep the area clean. That's awful important. Keep the floor clear of scraps and woods and extension cords. Next slide shows a bundle of extension cords. Don't trip over something like that next to your table saw. Keep them out of the way. One easy solution is the next slide. The extension cords are attached to the ceiling there. And I actually have something like that in my shop in a couple of places. Next slide. Don't work when you're tired. Don't drink when you're working, or medication that affects your judgment. That's kind of basic stuff. Be sure your tools are in good working order. A sharp tool is a safe tool. A dull tool is usually dangerous. You'll hurt yourself on a dull tool because you're going to put too much pressure on the tool to make a cut, especially with lathe wood turning Use the correct tool for the job. Don't use your hand. Your hand is not a mallet, and you can easily damage those blood vessels in there. You see that arteriogram with the lack of the blood vessels near the thumb there. The blood has been shut off, and something like that can also develop, next slide, into an aneurysm like this, requiring extensive surgery. So use a proper hammer. Don't use your hand. Next slide. Unplug tools when not in use. Especially unplug them when you're working on them, when you're adjusting them or something like that. Keep your tools sharp. Again, we mentioned that. Don't use your fingers to test for sharpness. Use safety features supplied with the tool. Leave the guards on the table saws. Leave the guards on the radial arm saws. Next is secure the work properly. Use clamps when you need them. Turn off the equipment between tasks. In other words, don't leave a lathe turning and walk across the room to pick up. Just turn the lathe off.
That'll happen.
That happens, yeah. Use appropriate speed for the task. That's important for router bits, especially. Some router bits that are large in diameter just can't go 25,000 RPM. Don't reach across equipment. That's one of the issues that, one of the papers I read for this talk, they talked about people reaching across a saw, across a table saw, or reaching where they shouldn't have reached for any kind of saw. Don't lift more than you can handle, obviously. Okay, now that I've gone through this, push sticks are important. Use these things. You can buy them. They're really cheap for table saws or radial arm saws, feather boards to hold work down onto the table. These are really important. Before we go into individual tools, I want to show you this. I bought this at one of the woodworking shows. It's one of the coolest things I've ever bought. It's a splinter remover that has a magnifying glass on it. You adjust it so that the tip of the tweezers is right under the magnifying glass. You can see the splinter really easily. It's a great little gadget. I think, Bob, we were going to do what the chop saw. Let me say something about the radial arm saw. Go next slide. Not many people have that saw now, but don't use it without the blade guard. Always have that guard on there, and of course keep your hands away from the cut line. You pull the saw this way. Don't put your hands in front of that saw blade. Use the blade with a zero. Next slide shows the different kinds of blades. You should have a zero. You see the tooth there. What that means, the zero in the middle means that goes straight down through the middle of that saw blade, and so the cut is at a 90-degree angle to the wood. A negative rake angle is to the right. A positive rake angle usually does not work well with a radial arm saw because it will try to climb on you. It'll try to pull itself forward. You have to continually keep it from pulling forward. And they say not to use a positive rake angle on a radial arm saw. Most blades in a table saw or other chop saws are usually positive rake angles. Try not to do that. Ted Baldwin, next slide. Ted Baldwin is a master at using radial arm saw because he can cut very tiny pieces, but he always clamps them down. He doesn't put his fingers near that blade. Keep your fingers 4 inches at least away from any blade like that. The dust collector, the radial arm is go next slide. Is a little tough to control the dust on a radial arm saw. This is, I think, Jerry Jones, and he has a nice little attachment you see right behind the blade that directs the dust into a bin there on the left. And I had never seen one of those before until I saw his. That's a pretty good contraption. Let's do the video on the chop saw. These are from the Mark Adams shop in, is that Nashville, Bob?
No,
Cincinnati.
It's not, okay. And these are 8 or 9 minute safety videos. First one's on chop saw. I actually finished quicker than I thought I was going to. So we might be able to see all of these. We've got one on chop saw, the jointer, planer, bandsaw, router, table, stationary sander, and table saw. We covered table saw with Bob a couple of weeks
I
ago.
want to talk about in terms of safety is a power miter box. And the reason I chose it to start with is because we didn't have these things 15 or 20 years ago. And you were probably never taught safety on them. And it can be very, very safe machines, but at the same time, if you don't run them the right way, it can be very dangerous machines. The first thing is you need to understand the control. The way this saw works is as the blade comes down, as it rotates, all of the forces are down into the bed and back up against the fence. And because of that, the cut is much safer. You don't have the kicking forces or the throwing forces that you have off of the table saw. Make sure that before you start anything, that your machine's unplugged as we're checking our setups. When I come to the machine, I want to be certain that my arms don't cross at any time. It's an ambidextrous machine. There's no reason why I can't run it with my right hand on the trigger or position myself over here to run it with my left hand on my trigger. And whenever you make angle cuts, you always want to be certain that you're pulling the blade away from your body instead of positioning yourself to pull into your body. So always work away. You've got 180 degrees here that you could stand and work at. When you run this trigger, you want to be certain that as you start the saw, you're all the way in the uppermost position. Because if you bring it down here and you try to start it low, the forces, the rotating forces, automatically kick the blade up. So have it all the way in the uppermost position. Pull on the trigger, let it build up to speed. Once it builds up to speed, then bring it down nice and slow and even into the cut. The last thing about the cut that's so incredibly important, and I'm going to demonstrate this in just a second, but as you make the cut, when you get done with the cut, let that blade stop down in that pocket. A lot of people make the cuts and then they let this thing come back up as fast as it can while the blade's still spinning. And since this has a brake on it, if that brake starts to kick in, it throws this whole machine forward. And look what it does. It re-exposes the blade. This shield, the further down I come, the more blade is exposed. And if you remember a second ago, we talked about exposure. And this is exactly what I meant. The other thing that's important, if you remember, I talked about the 12 and 3-inch rule. Well, the 3-inch rule, what that means is, when I hold my piece of wood, I want to be certain that I'm at least 3 inches away from my guard in this case, so my hand is going to be way over here. Never will I want to have it under 3 inches. Let me show you how to make a cut. With my piece of wood that I brought, one of the first things is it happens to have a bad cup in it on this one side. So much, in fact, that I could put my finger between the back of the board and that little sub-fence that I have in here. I wouldn't want to make that cut because it's going to cause a real pinching force on there. So instead, I always want to select my wood to have the straightest edge up against the fence. Let me make a cut. Plug it in first. And as I get ready to cut this piece of wood, I'm flat up against the fence. My hand is more than 3 inches away from the shield. I'm going to have it all the way in the upper position when I get ready to turn it on. Let it build up to speed. Bring it down nice and easy through the cut. And then let the blade stop all the way down in that pocket before I let it come back up. It'll be physically impossible to get cut if you've got one hand on the trigger and one hand 3 inches away or more. Bring the blade down and leave it down in that pocket. I can't stress that enough. I think one of the most important safety things you can do for a chop saw is to put this little sub-fence on by carpet taping it. I've just taken, it could be a scrap piece of anything. I've taken some exterior grade carpet tape and put on the back, and I've stuck it on. Now this is a piece of melamine, which is nice. The reason to put this fence on is it does 3 things. First of all, it eliminates any kickback that you might have through that little opening. It also helps you to line up where your cut's going to be because I can see exactly where the right-hand side of the blade is going to cut and exactly where the left-hand side of the blade is going to cut. As well as it'll help to eliminate any tear out in your cut. So this little sub-fence is a wonderful addition to any chop saw, plus it makes things considerably safer. The last thing is to talk about some type of stopping system. I've got a stop over here that we've made for making duplicate cuts. And on this stop, I just want you to notice that everything's been double clamped. By double clamping it, it helps to make sure that your stop doesn't move as you continually take pieces and butt into it for the next one and for the next one and for the next one. The point is this: it's not a good idea to hold over here on this side when you make a cut, leaving the piece that's captured between the stop and the blade. Instead, it's better to hold that piece between the fence and the stop as you make your cut. That way, by holding a piece that's captured between the stop and the blade, it'll keep it from vibrating and shifting and maybe even damaging your blade, or worse yet, hurting yourself. Be aware that the chop saw does have limitations. And when you look at it, we can't cut any wider than how wide we are from the fence to the front of the blade. And at the same time, there are some thickness limitations. But the real concern I have is when we start to cut parts that are too small. And what I mean by too small is anything less than 3 or 4 inches in length, because then what happens is my hand gets too close and it starts to violate my 3-inch rule. So at that point in time, you can take a piece of carpet tape and stick your thin piece to a bigger piece and then cut it down from there. But always be aware, this machine, as all others, does have limitations. Here are a few safety highlights for your power miter box or chop saw. Never cross your arms. Always use the 3-inch rule. Start with the saw in the uppermost position. Let the motor build up to speed, then bring the saw down in a slow and controlled manner. Once the cut has been made, let out on the trigger and keep your blade in the pocket. Don't let it raise up until the blade has come to a complete stop. Make sure that the guard is working properly and has no chips or cutoffs inside its housing. Never stick your hand inside the guard or around the blade. Always position your body to give you the best view and safest grip. Remember, this saw is ambidextrous. You can use the trigger with either your right hand or with your left hand. The jointer can be one of the most...
Yeah, go ahead and do the jointer. You want to go ahead and do most of these? What's this 9?
Okay.
It's 15 to 10 now. Let's do the jointer next. Jointer is a particularly nasty injury, a tool that will cause a really bad injury. Table saw is one too, but let's see what it says about the jointer.
First machines in this shop. So there's a lot that we need to go through to talk about safety on it. The first thing, though, is that you understand that it definitely has specific size limitations. First of all, I recommend that you keep your cuts to within a 1/16 of an inch. Try not to push over that. I mean, it's better to make a repetitive pass, several passes, than to try to take it all off at one time. There are limitations on how wide a board you can cut, obviously, including how wide the jointer is. So we're limited there, too. In terms of the lengths of a piece of wood, I would not run anything under 8 inches in length. It just gets to be way too dangerous. At the same time, I would never run anything under 3/4 of an inch in its thickness, because then it gets to be just a little bit too thin. So I have limitations. I suggest that you look at the owner's manuals to read what size limitations your joiner manufacturer recommends. On a joiner, you have an in-feed side and you have an out-feed side. It's important that the out-feed table be exactly set at the same height as the arc of your cutter. Some important things to know at the joiner is, first of all, stance. How do I stand? The worst thing that you can do is stand flat-footed, perpendicular to the machine, and then try to feed your piece through like this. Instead, stand with your feet parallel to the machine, so that as I'm working at it, I can literally walk with my piece through the cut. Very, very important. The other thing is how you hold your hands. And a lot of people stand at the machine And they work, and then they work, and they work, and all their forces are from the in-feed side. I'll talk about that in just a second. But more importantly, I think it's important to dedicate one hand as a push hand and one hand as a hold down hand. That'll give you a lot more control. So for me, as I send my piece through, this hand will be the hold down hand, and this hand will be my push hand. That way they have specific jobs that they're being asked to do, and I'm not fighting myself with both hands trying to push and hold down at the same time. That's very, very important. So how we stand and how we push our piece are some of the most important things with manipulating boards through the joiner. The next thing on the joiner is that I want to absolutely take advantage of my control. The control on here is my fence to my table. This is my 90-degree pocket. So I want to be absolutely certain when I'm holding down my work that I'm pushing into the fence, and then I use my thumb to hold down. So I'll hold my piece of wood like this. All of the importance on a cut off of a joiner needs to be based on the outfeed side of the table, over here. A lot of people will send a board through and they concentrate on holding their board from this side. But this is not the important side of the joiner. The cut hasn't taken place yet. Where you want to concentrate is you want to concentrate on holding down your piece after the cut. So for me, I'll get my hands while I'm making a cut. Now never take my hands over the blade. And remember, we've got this 3-inch zone here where we definitely want to keep our hands away from. But I'll take my hand immediately to this side of the joiner. I'll plant it down on the table, and then I'll put my thumb or my fingers pushing into the fence, and my thumb or my fingers holding down to keep it in that control pocket as I continue to send that board through the rest of the way. Another thing is my stance. I've got my hip touching the machine. It gives me more control in my cut. So let me plug it in and make a cut. Once I've got the depth of cut set, I'm ready to make a pass. So what I'm going to do is I'm going to start off on this side. My feet are parallel. I want to be sure that I've got a good hold down on my piece. I'll turn it on, and I'm going to make the pass. And when the pass is done, there was something that you weren't able to see, and I want to show you that. First of all, hand didn't, at no time went over the cutter. This hand did, but according to my rule, my 3-inch rule, you didn't see this, my fingers were touching the top of this fence the whole way through. So even if the board had slipped, pushed down, or even started to kick back, my hand couldn't have gone anywhere because I was using the fence as its own safety device for my fingers. The other thing is by concentrating all of my efforts and energies on the outfeed side of the fence, if I were to slip, I slip to the back side of the blade. But if I'm concentrating on the infeed and I slip, I fall into the blade. So I can't stress how important that is. The last thing on the joiner that I think is important to talk about is face joining. And with face joining, that's where we're going to take the piece and we're going to hold it perfectly flat as we send it through. Now earlier I mentioned that you can't really safely join under 3/4 of an inch. Well, the first thing is you never, ever, ever put your hands just right on top of the board as you're sending it into the cutter. If something were to happen for some reason, a knot were to catch and your body were to still go forward, you have nothing between you and the blades. So on face joining operations, you always want to have some type of device between you and the board and the cutter. In this case, I'd use these little paddles like this. I think they're absolutely excellent. I would not have my hands on the board. I would have my hands here. Now be aware that these paddle handles have angles on them. And I want to be certain that my hand is pushing the way I want to feed into the fence with this angle on this. I don't want to have it pushing the other way because I have a tendency to want to tip. So be aware there's a correct way to hand hold these paddles. From there, let me show you how to make this cut. You always want to be certain that you push your piece way beyond the back of the cutter. When you lift it up, carry it away from over the top of the blade. So even though we have our guard in place, if I were to still drop it, it could hit that guard, and that guard can be knocked out of place or damaged. Here are a few safety highlights for your joiner. Always use the 3-inch rule. Never pass your hands directly over the cutters. Try to avoid cuts greater than 1/16 of an inch in depth. Do not back your work out of the cut. Keep it going in the direction toward the outfeed table. Never operate the machine with the guards off. It's a good practice to use your left hand as the hold down and your right hand as the push hand. Hold the stock firmly at all times. Never use your thumbs as push pins. Position your stance to allow you to walk through with the board. Never stand flat-footed facing the fence.
Let's go ahead and
Do the planer too?
do a
Okay.
planer, yeah. Jointer planer was one of the top injury producing
The
tools.
planer is a great machine. It's one of the safest machines in the shop. But if you were to get hurt on it, it would be one of the worst injuries you could get. Where the other machines have a lot of control, the fence to the bed to the blade, you have no control on a planer. You put the piece in and it feeds it through for you. So we don't have the issues that we had before. One of the reasons it's so much safer. The issue that I'm concerned with on a planer as we start the whole thing are pinch points. There's so many places where you can get hurt or pinched and pinched pretty bad. First one is when I take a piece of wood, I've got to be certain that I don't have my hands underneath it as I set it down. Or if I've got any grooves or notches cut into the piece of wood, that my fingers aren't sitting into those. Because the in-feed and out-feed roller push with so much force that it can literally pinch your finger completely off. So be aware, familiarize yourself on the planer with the pinch points. On the planer as well, you always want to be certain that you inspect your wood for where your knots, cracks, splits, things are that might break or fall off as it's being fed through, because that can create a terrible kickback as the cutter hits that loose knot. Don't ever look down into the planer while it's running, and make sure you always feed your work in from one side. Don't ever stand directly behind your work. Although kickback off of a planer is highly unlikely, it can happen. So set yourself up for success here. Don't stand directly behind. The first thing you need to do on the planer as you run your boards through is evaluate their size. We do have, again, specific limitations off this machine. I recommend that you never run a piece less than 12 inches in length unless it's backed up or supported by another piece. At the same time, I don't recommend you run anything under 3/8 of an inch in its thickness unless you have some type of backing board in there, such as this one, and make it considerably safer for those thin pieces. The other thing on it is that I recommend that in terms of its thickness, most of these machines will go down to 4 or 5 inches. But when we come into our depth of cut, that you never exceed a 1/16 of an inch. Again, like on the joiner, nice, light, moderate passes. So I've checked the thickness on this piece of wood, and it's 1 inch thick. So I want to make a cut that's about a 1/16 of an inch less than that. So I'll crank my table to 15/16. Lock it down good and tight. Make sure all of your guards are in place. And I recommend you have some type of dust collection system. And then I should be ready to cut. Again, I'll just go through things mentally one more time. I'm going to stand to the side. I've got the face down that I want to send down. I'm going to watch for my pinch points. I think I'm ready to go. Be aware, you want to make sure that as a piece feeds through, that you watch for a pinch point like this one right here. This would absolutely be disastrous. So keep your hands on top of your boards as they go in or out of your planer.
I want to pause for a moment there and stress that situation with those rollers. That piece of wood there is trapped. The thing is only going to go in one direction, and there are in-feed rollers on the front and back side of that thing, and a planer is a right powerful instrument, especially a Powermatic like that one. I have dealt with industrial injuries and so forth several times where engineers that ought to know better got involved in the in the mechanism with, this is especially with roller conveyor, but the same principles applied. When you've got something being propelled, some flat object being propelled against a roller, that's time for the little tingly sense to go off in your head that you got a big potential to get pinched there. Powermatic realized, I guess after a few lawsuits, that was a big issue. That was an older Powermatic design there. We've got another one of those modern Powermatic machines just outside the classroom here, where they have replaced those rollers with a flat in-feed and out-feed table that is much safer. Okay, continue here.
We got 4 more: bandsaw, router, table, stationary sanders, and table saw. If you want to see all of
Here
them.
are a few safety highlights for your planer. Always use the 3-inch rule. Keep your hands 3 inches away from the in-feed and out-feed sides of the table in order to avoid being pulled in. Always keep your guards in place and use dust collection systems. Check the wood for defects such as large knots that might cause the board to split or crack or fall out under the pressure of the in-feed and out-feed rollers and the cutter. Always work within the limitations of the machine. Never stick your hands inside the machine and watch for the pinch points. Never wear gloves at a planer. Always give your work your undivided attention. The bandsaw can be the most versatile saw in the shop. One of the problems with the bandsaw is that the blade is adjustable. We can put tension on it, and we can adjust it in and out. You can't do that with any of the other saws. Some things that we want to point out. First of all, there are no real guards on bandsaws. There are guides down here, like these, and this little protective device up here just protects the exposed part of the blade up in this part of the saw, but it doesn't do anything to protect my hands down here where the cut takes place. So you have to especially follow our 3-inch rule around the bandsaw. The other thing is you can only get cut on a bandsaw going into the blade. The blade does not cut on either side or on the back. It only cuts from the front side. And because of that, while I'm making cuts, if I'm pushing into the blade, if I slip, I can fall into the blade. The best place to put your hands on a bandsaw while you're making a cut would be to the back side of the blade as you push or work your piece through. Because then if you slip, you're falling away from the blade. Let me show you some other things. On the inside of the saw, here's our blade. When you put the blade on, it's important to tension it properly. Well, there's all kinds of guidelines for how much tensioning to put in, but what I find works best is to tighten it down so that when you push it with your finger, it deflects by about 1/4 of an inch or less. No more than that. On top of that, we have these little bearings down here that guide the blade through the cut. They also keep the blade, see here, it flexes. We don't want that blade flexing in the cut. So by having the guide and a guide underneath, between those two guides, it keeps the blade more taut and straight. So it should be a good rule in the bandsaws you're setting up to make a cut that the height of these always be no more in height. I mean, I wouldn't want to cut this piece with this all the way up here. First of all, it's going to give me more blade exposure. Second of all, it's going to give me a lot more flex. So I always want to set these guides so that they're just about the thickness of my fingers above the height of my workpiece. Again, always make sure that this little shield's in place just to keep as much of the blade exposure down as possible. It is okay on a bandsaw while you're making cuts to push in, and as long as it's a straight cut, you can always back right back out again. But you can't do that on curve cuts. And the other thing that's important on a bandsaw, and this is absolutely, for as far as I'm concerned, it just drives me nuts when people do this, as you make little cutoffs and you've got those little chips laying next to the blade, don't take a piece of wood and try to knock them out of the way. Shut the saw off, wait for the blade to come to a complete stop, then you can move them out after the blade is stopped. Another important issue on the bandsaw that I want to be certain that we discuss is the fact that the control is this way. The blade is pulling straight down into the bed of the table. So you can cut things perfectly flat with total control. And that blade will only cut when you push forward. So if I turn on the blade right now and push this piece in, if I stop, it'll stop cutting. It won't cut again until I push on further. It's also important that you understand with this control why you can't cut things that are round. If something's round, as the blade is pulling down, it'll start just to spin and go in. It'll be very, very dangerous. It's always about control. Now I can get control by taking just a V-block like this that has a flat bottom that will allow me to support my piece in for the cut. I can also feed my V-block in this way if I need to. And it's really important that if you're making resaw cuts, without getting into the technique of resawing, but the safe way to do it is as you start it on this side, you always want to be certain that you're not pushing into the blade with your hands. And as quickly as you can, get your hands to the back side to finish feeding that piece of work on. That way, if I slip, I'm falling again away from the blade. Remember now, you have that 3-inch zone around here that we have to keep our hands out of at all times. And don't use your thumbs like a push stick as you're sending things through. If you need a push stick, grab a push stick. But don't push with your thumb as you send your work through. Here are a few safety highlights for your bandsaw. Since there are no real guards on the bandsaw, it's important to always be aware of the 3-inch rule. Make sure that the blade tension and blade tracking are properly adjusted. Do not attempt to cut short stock, or do not attempt to cut short stock that's not flat on the bottom. Keep a balanced stance while working in the machine. Never try to pick up or push away small pieces while the blade is still moving. Never use your thumbs as push sticks. It's okay to resaw on the bandsaw, and it's okay to back out of straight cuts. Never back out of a curved cut.
Let me touch on one thing that he didn't cover there. That is on a bandsaw. I think most of us have them. The temptation is to do, a lot of resaw type stuff. Take a big thick piece of wood or something like that, and maybe cut 2 or 3/4 inch pieces out of it. Commonly, that's done with a fence, perhaps a tall one. I will oftentimes cut a 6 or 8 inch wide piece of material. Take a resaw cut to cut a piece of veneer or something like that, thick veneer. One of the things that I would caution you against is when you're doing that, the thing that will frequently creep up on you that'll be a big surprise when it happens is you'll get blade drift sometimes within the piece of wood. So you would expect that blade to be perfectly vertical, but due to stresses and knots and all kinds of peculiarities in a piece of organic material like wood, that blade will take a curvature. And you're going along, you're concentrating like everything, and you've got that hand dutifully up against the side of that piece of wood, pushing it through the blade. All of a sudden the blade will peek out through the side of that piece of wood and you're cut. So keep your hand behind the blade as you're trying to feed that stuff through in a resaw condition. And keep in mind that blade can creep out, especially when you got it fully involved in a fairly tall piece of wood.
Bob,
Yes, sir.
I found that whenever that usually is happening is you probably need to replace the blade.
Mm-hmm.
Because the set in the blade is cutting more on one side than it is on the other side.
Yeah, I've not had that condition happen to me. I just happened to read that and see a video of it. But I would agree with you. I probably changed.
Well, it starts loading up the bandsaw and it makes it start running slower and the wood starts smoking and burning.
Mm-hmm.
Don't ask me how I know that.
Another thing he didn't address relief cuts either. on when you're cutting curves.
Yeah.
He didn't address going in and making relief cuts so that whenever you're cutting around the curve, the wood would literally fall away from your cut.
Oh, yeah, yeah. For those of you with a bandsaw, one of the handy books to read, Lonnie Bird has one of the best books I've seen on tips and techniques and safety issues with the use of a bandsaw. I'd hardly recommend you either get a copy of it or borrow somebody else's and look at it.
Another thing, if you're cutting curves, I think sometimes if you know you're gonna be cutting a fair number of curves with the same blade, is to take something like a Indian combination stone or something like that, and touch the back corners of the blade just to take those corners off. Because it'll make the blade turn better, and it'll give you something to rest the wood against.
Yeah, I do that with any blade that I set up,
Yeah.
regardless of whether I'm going to cut curves or not. It just it marks the wood less as you go through there. Any questions on that before we proceed?
Router tables, like shapers, can be pretty dangerous machines. There are a lot of things that we need to go through to talk about safety on getting the most out of this type of tool. First of all, there are limitations. You don't want to try to cut anything too small, and you don't want to try to cut anything too big and unwieldy to be able to handle. What those rules are have to be up to your own comfort zones. To me, some more important things about using your router table are devices that you can use to help you safely send and hold your pieces through during your cuts. So I want to go through some of these to start with, and then we'll actually make some cuts. The other thing I want you to remember is with the router table or with the shaper, moderation is the key. Nice, light passes. Don't try to take a raised panel cut all in one pass. Nice, light passes. First of all, with our router table, there's a handful of fixtures I want to go through. This is a really nice fixture here. It's a hold-down device. And what it does is it helps to hold your workpiece down because it has this built-in spring effect to it. You can see it's just a big chunk of wood that we've cut out. We've cut some compression slots in it, drilled a few holes, and as I push my piece through, that'll compress on it, helping to hold it down. It's a real clever hold-down. Fingerboards do the same type thing. I could clamp this up above to help hold my workpiece down. I could use it on my table this direction to help push my piece into the fence. All the control on this cut has to come off of the fence and down on the table, so I always want to keep things tight in that pocket. Here's a nice little push stick. This is a little bit different. What it has is it has a little hook on this back end. And when I run my piece of wood through, as I get close, it'll hook back behind. My hand can be way over here, and yet at the same time, I'll still be able to push it through with total control because of that little hook. This is nice. Our fence stands up really nice and tall, and we've made a fixture that looks like this. And this fixture hooks over the fence, so it itself will act as a push stick, helping to push pieces through on the cut. Well, let me show you how to make a few different types of cuts that can be dangerous to do. On a router table, it's very important that you always feed from right to left. When you handhold the router, we change our hemisphere, and then you need to feed from left to right. But on a router table, it's from the right to the left. One of my special challenges that I want to try to address today is what if I wanted to cut some type of molding on this piece of wood that was much bigger than the piece of wood as itself. So in my router table right now, I have a 5/8 of an inch roundover bit. Way more than I could handle if I'm trying to send it through. So how I would solve this type of problem is instead of running feather boards and some type of hold down, I would take a whole parallel fence, just a nice board that's long and straight. I'd put it down and I'd push in tight to the fence against my piece of wood. Then I'd come back and I'd clamp down both sides. After the clamps are tight, I need some type of a push stick device. And this is what I've made. It's just a 1/4 inch thick piece of plywood that has this little hook on the back side. And what that'll do is it'll hook on the back of my wood but at the same time, my vector of how I push pushes downward into the cut, so I'll have total control. I don't want to use this push stick until I need to. I have more control with my hands while I'm starting my push back here. But when I get up into that 3-inch zone, that's when I'll pick this up to continue pushing on through the rest of the way. Let me show you how. I have everything ready to go. I'm feeding from left to right, turn on the router, and make the cut.
Sure, the quiet router, isn't it?
And right there, I've just made this nice round over very safely. I did it because I fed from my right to my left, and I had a good hold down device and a good push stick device. Let me show you how to do curved work or curved raised panel doors safely. On a router table, you can do all kinds of irregular cuts. Some things to be aware of though, you always push or feed into the direction of the rotation of the cut. And there's no place where that's more important than doing freehand cutting. Freehand cutting would be the same as cutting this raised panel door throughout this curve. You can't do this with the fence. It's got to be one-on-one. So what I find the best way to do that, some router tables give you little starter pins that come in here, and then you go off the starter pin and pivot into the cut. I think that's a little dangerous. What I have, and what I recommend, is a full half fence that runs all the way through this half. No breaks, no interruptions. On the top side of mine, I've also put a little piece of plastic that's going to go over the blade. To stick this down on the back side, I put some exterior grade carpet tape. I'll peel that off. I do need to be certain that the outside edge is in line with this bearing. So before I stick it down, and by the way, this edge can't go beyond the halfway point of the bearing this way. So it's to the halfway point of the bearing and to the edge of the bearing that I'm after. So before I stick it down, I'll take a straight edge, put on my bearing, slide my piece of wood to the halfway point on the bearing, and then stick it down. Make good contact with the tape. And what this allows me to do is take my curve shape. I can start out on the fence, get onto the bearing, and then at that point in time, I'll be able to pivot into my cut. Let me show you how. By having a half fence, if I ever get in trouble on this cut, I can always go back up against that solid surface. But with a pivot point, I can't do that. You saw how easy it was for me to move through. I was very aware of my hands. I kept them at least 3 inches away from this shield at all times. This is what and how I think is the best way to cut curved raised panel doors on a router table or on a shaper. Here are a few safety highlights for your router table. Always follow the 3-inch rule and know the limitations and hazards of using the router table. Never pass your hands directly over or in front of the router bed. Use push sticks. Always feed your work into the opposite direction of the cutters or feed from right to left. Clean, sharp tools give safer and better performance. Always unplug the machine when changing cutters. I also want to discuss safety on 3 different types of stationary sanders: an edge sander, an oscillating drum sander, and a disc sander. And sometimes these aren't thought of as quite as intimidating as table saws and joiners, but yet, to be honest with you, they're some of the most dangerous pieces of equipment in the shop. They have no guards. And because of that, sometimes our brain goes into park and we don't think about it. But you've got to be aware of certain aspects of these machines. So let's go through them. First of all, on a disc sander like this one, the way the disc rotates, one side, it pushes your piece of work down into the bed, which is the side that you want to work on. You can't use the whole disc. If I were to push my piece of wood in on this side, the way it lifts while this thing is spinning, that piece is going to kick back as hard and as fast as it ever would off of a table saw. So you have to be aware of the rotation. You only work on one half of the disc at a time. The other thing in terms of these machines is limitations. Believe it or not, they're really not limited at all, because you can take very small pieces, such as this little key piece, and I can sand it perfectly. I don't have to turn the machine on to sand small pieces. I can just simply hand hold it and slide it back and forth. Or with most discs, they're freewheeling, so I could just spin it and I could work off of the side and do any of my sanding. So it doesn't have to be on to be able to use it. These machines excel at sanding curved surfaces. So if I wanted to sand the edges of this tabletop where they're nicely curved, this is the perfect machine to do it on. Again, concentrate on only using the half that's rotating down into the bed. My next concern on these machines are for pinch points. As they rotate, they create some absolutely dangerous points. The first one would be right along this edge. Now, usually your table should be set as close to the sandpaper as possible so nothing can be pulled down in here. But my other concern are for these edges on each side. As this pulls down, there's a terrible pinch point off of this machine. It's about a 1/4 inch wide gap right here. And I've got to be very, very much aware of that. Always follow my 3-inch rule. I've got to do everything I can to be especially aware while this is spinning to keep my hands 3 inches away. My rule is usually 3 inches away from the guard. But since we don't have a guard, I want to be certain that my rule is followed by keeping my hand as far away as I possibly can. And be aware, while you're using this machine and you're doing curve work like this, you don't have nearly the control up close trying to sand this curve as I do working it from back here. So sometimes your hands don't have to be very close in order to have more leverage or more control on what it is that you're sanding. These machines can be dangerous. Be aware. This oscillating drum sander seems to be about the safest machine in the shop. But there are two things that really concern me. Number one are these terrible pinch points. So you always want to be certain that you have some type of a zero tolerance insert in there to eliminate as much of that pinch point as possible. The other thing is these sanders, these spindle sanders, have a tendency to rotate around and lift up and down, oscillate. And because of that, they have a lifting effect. So you have to absolutely be certain that while you're working in the machine, not only are you pushing into the machine, but you're holding your work down. As we look at this one, up and down. I made certain that as I ran my piece through, I was holding it down. These work best on round or curved surfaces. And again, they don't have to be turned on in order to use them to sand pieces of wood. Oscillating drum sander. The edge sander is a wonderful machine, but it's exactly that, for sanding edges. A lot of people get confused and they think that they can come up and do any type of curve work on it, but it's got a flat platen, and all of your control is off of this bed and off of this piece of paper that comes up at a perpendicular angle. And if you start doing curve work on it, these machines have a tremendous bite and a lot of kickback, so you have to be especially aware of that. You have some tremendous pinch points that you've got to watch for. We've got a long pinch point along this edge. And I've also put on a little auxiliary fence for a little additional control. It allows me to make sure that I always have a 90-degree in thrust if I need to go in to my end grains at exactly 90 degrees. And it helps to support my piece when I get ready to sand in this way to eliminate this horrible bite and the kickback. I mean, you can get as much kickback off one of these sanders as you can on your table saw. Some other things to be aware of are that there are no guards other than this guard up here and this guard down here to protect us from getting into the pulleys. So you have to be especially aware of your 3-inch rule. Other things that I think are important to know are that you don't ever want to do small parts while this is running. Instead, if I had a small piece that had intricate shape on it, I can leave the machine off just like we did on the disc sander, and I can slide this back and forth this way to be able to do any sanding. So the belt doesn't.
Glasses, but I haven't really found any on this side. Have you ever seen any that?
Okay, one thing in conclusion here, As we were watching those Mark Adams videos, I want y'all to make note of how many times he mentioned control. As you're approaching a tool and getting set up to make some kind of a cut, you need to think about that. Am I going to be able to make this thing from start to finish and maintain control? If you can't answer yes to that, you're in a potentially risky situation. So, Jim, did you have anything you wanted to add?
Oh, well, just, I guess in conclusion, just common sense is one of the most important things. Don't defeat the guards on your machines. Maintain the 3-inch rule or 4-inch rule. That's about it. Thank you.